right, very good, thank you. Good afternoon, everyone. I think I'm the last one standing between you and drinks and food, so I'll try to be brief. What I'm will do in this session is take you on a little walk across the Kubernetes across the manufacturer and the different places where it gets used. I'm not going to make a big case on why you should adopt IoT or why you should adopt Kubernetes in manufacturing environments, because you already know why you should do that. That's why you're here. But there are definitely challenges that will happen in these different environments that put requirements on the type of products that you select. And since we have a number of customers in these different layers of where manufacturing operates, I have some interesting perspectives to share with you that can help you along your way as you decide what kind of properties the products need to have that you select in these. There are some common factors around that, and then we'll close out and I'll take any questions if there's anything that you still want to ask instead of getting a beer outside. So these are the main environments where that are related to manufacturing, where we see Kubernetes being used in some way, shape, or form. So it starts from more directly in the enterprise data center that is remotely controlling manufacturing environments. It is directly in OT environments where there's like factory lines, for example, where it is at either a warehouse or a factory location where you get very different requirements around resiliency instead of just consistency and repeatability. These environments also have different connectivity characteristics that you have to consider. It can go even further where we're getting into more warehouse operations and what we call distributed edge, where you might be providing a component that needs to operate there, but you don't control the environment. So it needs to operate in external customer environments, needs to be very flexible with how it can be configured, and it's locations that you don't ever want to visit yourselves if there's a problem. And that can go all the way to what we call connected products, where you're basically selling to the end customer directly, where you really get to scale. And these things have to be very self-reliant. They will be in unsecured environments. There's no physical security. So then data security and manageability at scale become very important. There's common threads along all of these, but the nuances are very different. So let's take a look at a customer case on each of these. So before we do that, you'll see this graph on the top right for each one telling us basically where we are. And the fact that the bars go up basically mean that within the data center, it is fairly straightforward in what you can focus on, because there's a lot that you do control. But the further out towards the edge that you go, you tend to see scale in the number of things that you have to manage and the number of challenges that you have to solve. And so that's why it looks like that. Starting with something directly in the enterprise. So this is a pharmaceutical manufacturer that's a customer of ours that ran a monolithic manufacturing execution system, MES. And they were already a Kubernetes user, and they decided to also shift this system from a monolithic system into a set of microservices. And it basically kickstarted their need to really look at consistency of Kubernetes deployment and cluster management. This is the one that's most like any type of customer or environment that wants to do Kubernetes as a service internally. they had the same kinds of requirements and challenges. So this is all about consistency in cluster management, being able to deploy clusters quickly, being able to do desired-based management, and basically trying to take away all the regular bottlenecks that internal engineering teams and operations teams will face when trying to support a growing number of customers. And so what was really key for them is leveraging automation to shorten delivery time. So they really went from 2 weeks to deploy a cluster with all the internal procedures that they had to about 20 minutes. Take away snowflakes, go to something that our product uses called a cluster profile, where you basically define the entire state of your Kubernetes cluster as a layer cake, and you apply that on a cluster, you use that to build a cluster, and you use that to make changes to clusters. And that is how you can get away with the whole idea of managing paths and having a form of operations that doesn't really scale. So you want to manage all components of the cluster. A lot of Kubernetes manufacturing software systems only allow you to automate, for example, the deployment of Kubernetes itself, but then everything on top tends to be very manual. You want to do that across the entire stack. So things like Cluster API, for example, is a good technology to look at to help automate deployment of Kubernetes. And then there are products like ours, but we're not the only one, to then automate all of the components that come on top of that as well. And so customers say, like, they're not going to build all of these clusters by hand. There has to be a platform that does that for them. So this is the most straightforward use case. When we look at production lines, it's a little different. Here it's about a monitoring application, so that monitors the state and can intervene in these different production lines. Again, it's Kubernetes based, everything is moving to Kubernetes, but these are 2,000 of these factory lines across, in this case, the US. And so we're talking about the inefficiencies of trying to do this in environments where connectivity is not a guarantee. So it needs to be fairly lightweight. It needs to also work if connectivity is bad or even temporarily gone. And it needs to give you the flexibility to use lower cost off-the-shelf components. And so what this customer did is they were able, through the edge technology that we provide with Spectrum Cloud Palette, to use off-the-shelf Intel NUCs as a way to create simple, highly available multi-node clusters that could be automatically deployed into these factory environments to act as local monitors, but be controlled from a central location and have this same way of deploying through a cluster profile. But they wouldn't need very specific hardware for this. They could just use Intel NUCs for this. It also means that you're doing edge Kubernetes, and then other items from this tend to be edge Kubernetes based as well. And that in itself is a hard nut to crack. So pre-staging devices, being able to survive complete network changes, because maybe you want to pre-stage in one location and then ship it to a different location. Or the requirement that it can live without a restriction or with a very low bandwidth restriction at times as well, all makes it very difficult to deploy a Kubernetes cluster and have it be fairly self-reliant in a remote location. And so you need things like immutable operating systems, so that if something goes bad, it can just be restarted. Or if it goes really bad, it can just be reset and automatically be redeployed with a touch of a button from a central management system. You want something like plug-and-play onboarding, where they can ship out the devices, and when they're turned on, they automatically register into a management system so that they can be automatically deployed. You want things like content caching, where the system is shipped with a copy of the content that's necessary, all the container images that are required, and then when it deploys itself, it leverages this existing content cache so that it doesn't have to download all of these images over what might be a very terrible connection in these locations. So this is where, especially around edge, there's all sorts of auxiliary and ancillary requirements that come into the picture that you have to consider when looking at these things. Now, another one that I hope that this customer, because this is a customer of ours, would be here, but unfortunately they're not, so I cannot point to them. But this is a customer that does packaging. So they have a big packaging machine, and they're adopting IoT, and they're trying to ship what they call a digital add-on, where it's basically a free option in the device, at least it is in the machine. And it lights up digital services that are part of this packaging machine. So it's like predictive analysis, reporting, some monitoring, where a customer can go to a dashboard and see all of this information about their machine. And they're basically trying that to deliver added value against the competition, and hopefully at some point in the future do add-on selling as well. So in order to do this, of course, the application is Kubernetes based. You need to somehow ship a piece of hardware. It's, in this case, I think it's 2 nodes, 2 machines in this machine that the customer can light up if they want to. And it should automatically just like register, deploy itself, and provide these services that the customer wants. That's pretty difficult because you're not quite sure what you're shipping this into. So you need a lot of flexibility here, because there are customers that will, where you say, and where you come in and you say, well, if you want to enable this option, you need to allow these particular types of traffic through your firewall to go to the outside, for example. But there are customers, and like one of their first pilot customers were a lot more strict and said that's fine if you want to communicate outbound, but the machine that is inside this edge device that is inside the machine on the factory network is not going to be allowed to talk to the internet directly. You will have to deploy another node that sits more on the customer network and has a leg into the factory network that is going to be allowed to talk to the outside. And you have to figure out how you make these things communicate through each other to make that work. And so that also posed a unique challenge to us as a software vendor to enable this to work, but we were able to get there, basically like deploying a Kubernetes cluster in 2 parts, where the first part is the thing at the more inside the customer network that can deploy itself as a 1-node cluster, enable proxying functionality, and then allow this other component that sits inside the factory network to also have proxied internet access in order to be able to install itself and install all the applications. So just the fact that you're going to have very different customer environments, some of these might not even allow you to use like pre-configured static IP addresses. We have some customers where this is all DHCP. And I don't know if you've tried deploying Kubernetes in DHCP environments, but it's not fun. This is something where we've created a capability called overlay networking, so that when you deploy a cluster in an environment that you don't control, these cluster nodes, they will build an overlay network with each other so that they can give each other static IP addresses in a VXLAN segment that never changes, while the actual network underneath can change all the time. And then these systems, they rediscover each other, they exchange the real IP addresses that they have so that the VXLAN segment can work on the new situation. And this is how we can get around these environments where you have no control over the networking, but you do have to provide a Kubernetes-based service in that location. And then finally, this is also a fun one, AI-based warehouse inventory. So this is from a global telco company. Used to be very, very known for their phones. And they run these drones, basically flying GPU, that do AI-based computer vision to inventory warehouses. So you let these fly around in your warehouse, and they figure out all of the barcodes on all the systems to automatically inventory your warehouse. This is another example of, that's fun, I'm going to run Kubernetes on a flying drone. And I have absolutely no control over the network that this runs in. So it needs to be very self-sustaining as well. Connectivity is also going to be interesting. So all of the content that it needs to be either fully locally, or it needs to be pre-cached so that only small updates are necessary. It's very similar to the first use case, but it brings it to an even bigger scale, because you can imagine that there's a lot of these that are necessary to facilitate this in a single warehouse, let alone multiples. So where this comes really quickly back to satisfaction is how easy it is to get this up and running. Because from a customer perspective, probably all they can do is turn it off and turn it on again when it doesn't work. So the system needs to be able to repair itself, reset itself, upgrade itself, all with basically having no more levers than turning it on and turning it off. And it might be off for an extended period of time. There's a different use case than this, but similar idea, where it's a company that sells equipment to dentists. And one of these is like a 3D scanner that takes a scan of the inside of your mouth for dentures. And when you sell that to a dentist and he goes on vacation, basically the entire environment is offline for up to a month. And that means that everything that happens there needs to be able to survive long periods of basically the entire system being offline. You can imagine that if you do that in a DHCP environment, all of your addresses are going to change as soon as you turn everything back on again. So, and another thing that happens here is security. So when you send drones, for example, it might be that those don't carry very particular information. Maybe they forward everything to a central server. But you can imagine that these systems for these dentists, they will have personal healthcare data. And so, but these devices sit in just a dentist office. There's no physical access security there. So these things need systems like secure boot and full disk encryption and tamper-proof immutable operating systems, live kernel patching, just so that you can be assured that even if the device gets stolen, the data on it is still safe. Especially with these connected products, as you saw me allude to in the last couple of slides, there are just a lot of different challenges that all come together in these things. So I mentioned these 3D modeling intraoral scanners. We also have a company called Teveltech that does apple picking with flying drones. They're also doing this with Kubernetes. It's all these sorts of examples where a device is somewhere where you don't have control over the environment, and you're definitely not going to want to visit that location yourself as a vendor. It all needs to be able to be done remotely, securely, and through some sort of central configuration and management system. And if you're considering that if it's not a Kubernetes system, then this is already pretty challenging, but then you add the fact that it's Kubernetes on top of that. And so this is on the right is from a presentation that I did about this provider for the dentists, where basically the iceberg of running Kubernetes at the edge, it's all of these difficult things. And vacations is the one that I alluded to earlier. So what's common in these? In order to do Kubernetes at scale anywhere, you probably require something that is desired-based state to do the automation around both deployment, management, and changes. So you want to fully eliminate any manual deployments, anything that takes a lot of time that has to go through multiple people. Use automation systems to do that, and use desired state-based so you can model these changes so they're reliably tested. You probably only have a few experts on Kubernetes and specific applications within that, within your company that can really master how this technology should work. They are unable to facilitate the scale by themselves. There's no way that they can manage all of these different customers themselves. So use those experts when you have them to model what we call the cluster profile, to model what the desired state should be across the clusters, so that the people under that, they can deal with the exceptions, they can deal with the issues that go wrong, but try to use your experts for where they're good at, which is setting up what will work in most cases and model that. And when you're doing this at the edge, it's very important to look for products that have built-in capabilities around self-healing, around content caching, and around immutability, as well as, especially if you're deploying into uncontrolled customer networks, something that can deal with changing environments, has something like dynamic overlay. Also, be aware that it could well be that the topology that you are expecting might not work. So it might be necessary that that the system that you select has the ability to reconfigure how it's deployed, where nodes go, and how they work together. But our customers keep telling us is that this is very much a skills issue, all of these things. So it's hard to find the people to do all of this. And when you get closer to manufacturing, it's actually even harder to find people that have both of these skills merged into one. So I hope with that, I didn't have to tell you that Kubernetes in manufacturing is the way forward, but I do believe that it is the way that all of these applications moving forward. Manufacturing makes a lot of sense to me. It is absolutely important that you focus on these core items on availability, security, manageability to be at the forefront of the solutions that you design, because especially in manufacturing, they are the most important items. And the products are available in the market to be successful with delivering Kubernetes in manufacturing environments. It's just important that you locate those products and that you use the capabilities that they provide to be successful in these environments. All right. Are there any questions? If not, here's a QR code that brings you to our customer story site, where there's a lot of examples of actual customers that are using our either regular cluster API-based Kubernetes management and deployment or edge-based Kubernetes management and deployment solutions to be successful in both healthcare and manufacturing. And I really welcome anyone to take a look there to see for yourself. All right, thank you. You have a question?
It's a lot of use cases you shared, right? And it seems like that you are like, you mentioned once that you don't want to go there as a vendor to do stuff. What's the developer, how's the customer experience? It sounds like a platform. Mm-hmm. Like people, probably this drone app is different from the app for the dentist.
Yes, the actual applications that they run are very different.
And how do they, is it like do they log into your platform and select their environment to deploy to? So it's like a developer integrated thing, so they don't have to interfere with the drones and the hardware that you're building?
Correct. So for a customer like that, everything looks like a Kubernetes cluster. So it's just a list of clusters for the backend of this, and these clusters have desired state, and the desired state includes these specific applications, middleware configurations that go on these clusters. And the way that they manage this fleet, so if we look at, for example, the Densely, Densely environment for the dentist offices, there are like hundreds and hundreds of clusters here, but they're all tied to centralized profiles that define their configurations. And so they can work at updating a central profile when they want to make a change, go to maybe a newer version, deploy a newer version of the application, and then they apply that to all of these different clusters. And they can do that in smaller groups or larger groups. And that facilitates the change at scale.
So the customer owns the code on the drone, the Docker image basically?
Yep.
And you own the platform to ship it?
Yes, yes. This is all about getting our customers the ability to ship their software that is Kubernetes based onto Kubernetes clusters wherever they need it to run. Yeah. Any other questions?
By desired state, you mean it's also GitOps supported? So
yeah, I'd say it's two parts. It's both the ability to create an entire layer cake like this, for example, or have different profiles that do parts of this. Well, maybe there would be one profile that configures, I don't know, like the monitoring agent, like a Prometheus agent that has forwarding to the right central monitoring system that you have as one add-on profile. And then that can be used in many different clusters, so that if you want to adjust what that agent does, there is one profile that you adjust centrally, and then all of these clusters will pick up those changes as necessary. But any of these profiles are essentially is the YAML code to either deploy a Helm chart or deploy a manifest or a combination of the two. That defines what the desired state is. And so you lock all of that knowledge and expertise. You use our experts to set this to exactly how you want it to work in your specific environment. If I showed you one of an actual customer, it would look like a cluster like this with, sorry, let's pick one that looks a little better. With endless layers and layers for all of the different things that they do, and they manage those things centrally. There's, I think, 8 or 9 profiles stacked on top of each other, and there are different teams that own different components of that, and so those teams they can update that centrally, and then they can improve the entire fleet as a whole. But this is how you approach that. Yep. Any other questions? See what the time is. All right, 5:15. I think it's time for a beer. Thank you all.